Hello everyone. Welcome to this tutorial on building a pizza ordering system using a layered architecture with Spring MVC, JPA, and MySQL. Today, we'll be starting first with knowing what will be our end product, what we are trying to develop, how the functionality will be there, and what all features are there which we need to include. So this is the home or landing page of our application which we'll be trying to develop. In this, you can see there are two hyperlinks over here. When I click on save order, it redirects me to a page where I can add my pizza detail. And once I click on order, this order should get saved in my database. Going back to the home screen, there's an order report hyperlink. When I click on this, it will redirect me to the order report page where we can view our report, which will be fetched from the database itself based on the minimum price and maximum price, whatever we'll enter here. So before proceeding further, let me first show you how my database looks like right now. So let me open my SQL terminal, password, show databases. Okay, so in this we have multiple database from which what database we are using I'll show in the code itself as well. However, over here we are using Spring MVC demos. So let's copy this, use Spring MVC demos, show tables. Okay, so in this database we have two tables, pizza and pizza order. So in pizza what we have is select start from pizza. Oh, spelling mistake. As you can see in the pizza table, we have all these records of pizza. What are the different categories of pizza which we saved? Okay. Now let's see what we have in pizza order table. Okay. So in pizza order table, we have six customer records with different customer names, their contact numbers, pizza ID, number of pieces ordered, and bill. So this is the final bill amount on which we are filtering. So let's go back to our page, home page, and let's try to add one pizza over here. So let's go to save order. Let's say the name is ABD, contact number is this, and pizza size is XYZ, non-veg special, quantity is 7. And when I click on order, before clicking on order, there is no ABD in this record, but however, once I click on order, it should store this detail in my database. So let's click on it. This is the page where we got redirected with a message saying, "Hi ABD, your order is placed with an order ID 5009. Bill to be paid is this much." Now let's see. Okay. So another record with order ID 5009 is created over here with the name ABD, this contact number, whichever I said, and pizza ID. So since I selected pizza, which was of category XYZ non-veg special, it was of category 1008. So it is linked over here 1008, and number of pieces which I mentioned was 7. So 7 is here, and this is the total amount which is calculated by using this price. So 900 into 7. So this all functionalities is something which we have to write in our Java code. Going back to the home page, let's go to the order report page. In this page, let's give minimum as 0 and maximum as 1000. So before fetching details, let's go back to the MySQL database. You can see out of this 7 records, the records with more than 1000 bill amount is these 4 records. So when I click on fetch, these 4 records should be fetched. Let's see. Correct. So 1, 2, 3, 4 with the amount as 200, 400, 600, and 800. So it is in the range 0 to 1000. Now let's say I create range as 10,000 and fetch details. So all the details will be fetched because The maximum limit over here is the maximum amount over here is 6,300. Now if I create minimum as 1,000, then after removing first four records, rest three will be printed. Fetch, and we can see. So this is how this report page is working, going back to the home page. Now, while directing from one page to another page, if you would have observed this URL, it is changing. So when I click on save record, it goes to load pizzaorder.html. When I click on home, it come back to index.jsp page. When I click on order report, it goes back to load bill range.html. So these are the different home pages. So whatever we are looking at right now is called as view. Since it is at the client side and client is interacting with it, it is called as view. So whatever pages we get redirected is view. Now, when I save any order, when it gets saved in database, so when I click on order, there will be some processing happening. Let's create another detail. Okay, so there are some checks as well. For example, in contact number, if I only enter 9 number and try to select something as quantity 1 and try to order, so as per the check, there is an error saying that contact number should have length greater than 10. So these are the checks which we have to implement. So let's make it 10 and let's not enter quantity. However, we know that to calculate price, we require quantity. Let's try to order and we again have an error saying quantity should not be empty. So let's add quantity here. Let's do not select anything here and try to order. Please select a valid pizza. So these are the checks which we have to implement. Now, after selecting everything properly, let's try to order it. And there was no error. We got redirected to another page which is save pizza order.html and the price is calculated. The bill is generated with an ID. And this is how there are different page renderings, different checks, and we'll be implementing all this in our code. So what we see is view. Whatever redirection is taking place is handled by a controller. And when we deal with database, it is handled by model. So that's how model view controller MVC architecture works. Okay, so this is the end product which we are trying to develop. Now let's go and have a look at our code base. Now let's try to understand the project structure which we will be getting in our hands-on. What are the requirements that we have to complete? How the project structure will look like and how and where we have to write our code and all the settings that we have to do. So this is the project that we will get while doing hands-on. Something similar to this. So in this, we have Java resources, web content. In Java resources, if I expand, there is source src folder in which we have our home package and the respective packages. In the web content, we have meta inf and web inf. When I expand web inf, we have our JSPs and some config files and XML files. When I expand JSPs, we have our multiple JSPs over here. So out of this, one of the most important file over here is web.xml file because this is the main starting point of our whole project. Now in this web.xml file, we are mentioning welcome file list in which the welcome file is home.jsp. So whenever we'll be trying to run this application, it will at the launch time, the first page which we'll be looking at is home.jsp. This is what it is mentioning. Now, load on startup true over here says that whenever we'll be starting, this will be loaded, which is dispatcher servlet. This is very important while we are dispatching request for whatever request we'll be getting from .html pages. So this is the URL pattern. So for any URL pattern of .html, we'll be calling this, which we'll call dispatcher servlet, and then accordingly it will get dispatched over there. Now we are even mentioning what are our context config location. So the parameter name is context config location, and this is the location. If you can see in this location of web.inf, we have root config.xml, which include our config for two things. So first is what are the packages that we have to scan. So the two packages are service and DAO. These are the two base packages that we have to scan, and other it is important spring jpa config.xml file. Now where is this config.xml file? This is the one. Now in this spring jpa config.xml file, we have a bean defined over here. The bean class is property placeholder configurer. The location of it is connection.properties. So whenever we have to connect with the database, we require some credentials. Whatever details we require, we save it in this connection.properties sub. Now it is located in resources. So let's try to open resources, and you can see we have cst connection.properties. Now in this we have mentioned four uh, key value pair over here. So driver is MySQL driver, since we are using MySQL database. This is the URL where this is the port number and this is the database name. These are the username and passwords. So going back to Spring JPA config.xml file where we initialized our properties over here. So this was the property placeholder configurer. It will configure by using these properties. Now, next is transaction annotation driven transaction manager, TX manager. So this will be helping us for creating any transactions. So whenever we'll be dealing with the database, it is compulsory to create a transaction before executing anything and committing it after executing it. Then only it will be saved in the database. However, it was difficult in the beginning where we have to create an entity manager factory, then entity manager, then create a transaction, initialize it or start it, then commit, close, and all that process. It will be handled by this transaction manager, TX manager. Now, what are the GPA repositories base packages is we have DAO, and since DAO is responsible for dealing with the database, we are using transaction manager over here. Now we have a bean ID with the name data source, and we are initializing driver manager data source. And to do that, we need four parameters. The very first is driver class name, second is URL, third is username and password of our database. And we know all these are something which we stored in our properties already, and we can, you know, access it by using this dollar signature. So whatever we are using here is keys, and the respective values will be fetched from this cst connection.properties file. Next is this. Name of the bean should be entity manager factory only in Spring GPA data. So this is entity manager factory. Class is local entity manager factory, entity manager factory bean. The name is data source, reference is data source again. So what is reference? This is the reference which we are trying to have over here. Then property name is JPA vendor adapter. Now what we are doing over here is we'll be using JPA vendor. So we are not writing SQL query by our own. So which vendor we are using is Hibernate. And in Hibernate we have to uh, do some changes. So in Hibernate, we can update some properties, for example show SQL query. So since we are not writing SQL query by our own, for a simplicity we are using Hibernate as an JPA vendor adapter. So whatever SQL query it will write, it will be visible to us on our console. So this is what this show SQL query true equals to means. Then generate DDL, data definition language, is true. And then database platform is hibernate.dialect.mysql. Okay. When we are saying it will perform some SQL operation, so that operation will be performed on tables. However, the tables in Java is named as entities. Hence, in this, we are scanning package accenture.lcam.entity. Okay. Next, we again created a transaction manager for JPA transaction manager, and we passed entity manager factory over here as a reference. We passed entity manager factory over here, which we created above. So these transactions will be managed by this entity manager factory. So till now we try to understand all the XML files, what are the code written in it, what are the functions of that code, how they are linked with each other. Now, the final good news is we don't have to worry about all these XML files because it is already provided in the file structure which we'll be getting during our hands-on. However, it is really necessary to understand what are the functions of that files and how it is redirecting and how it is linked with each other. Now let's try to understand other code base which we have. So one of the most important part is bean. So whatever object we'll be dealing with, since we are dealing with Java, we'll be dealing with object, and we have to create different beans for different object. So for example, we have a bean for pizza. So this is the pizza bean. Then we have pizza order bean, and then we have pizza bill range bean. Now, what is bean? So, bean is nothing but a normal Pojo class. Pojo is plain old Java object. So, before proceeding further with the code, let's try to understand the problem statement that we'll be getting during our hands-on. So, this is the PDF of problem statement. In the problem statement, it is mentioned that this is the Dan Pizza store, which needs a portal to manage the customer orders. We have to create a web portal to fulfill the requirements. And to fulfill the requirement, the following functionalities needs to be implemented. The very first is save order, second is order report. As we already tried to understand how the web page will look like and what all functionalities will be there, now it will be easy for us to relate all that functionalities and how we have to code accordingly. Now, coming to the database, we have to create a tables name pizza and pizza order in MySQL database by following the description which is given below, and then we have to insert some records. So if you would have observed when I displayed my MySQL database, this was the exact structure which I followed. So I had two tables, one with pizza, another with pizza order, where I had pizza ID, pizza name, price, and in pizza order, we had order ID, customer name, customer number, pizza ID, number of pieces ordered, and bill amount. Correct. And these are the data types and their descriptions. Along with that, in pizza records, we there are just four records over here. We had some more records as well, and even in pizza order, we had some few records. So let's pull it up and try to understand if it's matching or not. Spring MVC demos. Okay, show tables. So these are the two tables which is mentioned in the problem statement, which we are using over here. And then if I say describe pizza, so we have pizza ID, pizza name, price, pizza ID, pizza name, price, and integer where caretable, integer where caretable as mentioned. We used 250 over here. They are mentioning 20 only, so we can update it accordingly. That's not an issue. And then this can't be null because pizza ID will be primary key. It is mentioned over here primary, and as you can see, this is the primary key. Now let's try to print record of pizza. So okay, so this is how we are printing the records, which was shown over here. Correct. Next is pizza order table. Let's try to open that. Describe pizza order. Oh, spelling mistake. Triple Z. Pizza order. Okay. So over here we have order ID, customer name, customer number, pizza ID, number of pieces ordered, and bill amount. And the data type is integer, varchar, int double, which is mentioned over here. Then we have primary key as order ID. And as it was mentioned over here, we have to make it auto increment. So this is how auto increment works. Then this pizza ID should be a foreign key of pizza tail. So that's what we did. This is a foreign key over here for this one. That's how it is working. And now let's try to print some records of it. Pizza order. And the same structure which is mentioned over here is here. Order ID, customer name, and all. Okay, I think we are good to go till now. Let's proceed further. Next is entity bean classes. We have to create entity bean classes named as pizza entity and pizza order entity and map to tables pizza and pizza order tables respectively. Generate getter and setter methods for all the properties. Okay, there are two properties, pizza entity and pizza order entity. Let's go to the code base. We have entity over here, this one, and in this we have pizza entity and pizza order entity, correct? Now what is mentioned is we have three things, integer, string, double. When they say generate getter and setter methods for all the properties, what properties is this three which is mentioned over here. So let me erase all other things from here. So let's say how to generate getter and setter methods. I'll tell you after removing this. So these are the three properties which we have as of now. Now to generate getter and setter method for this, we will do right click, source, and generate getter and setters for all three. Okay, and boom, we have our getter and setter methods ready. Okay, so that's what they were expecting. Similarly for pizza order entity, let's go to pizza order entity. We have, yeah, we have our properties and their respective getters and setters ready to. Cool. Now the next thing is bean classes. Create a bean class named as pizza bean, pizza order bean, bill range, which is already created over here. And as per the class diagram given below, generate getter and setter methods for all the properties. These bean classes can be used as data transfer object. So when they say data transfer object, it is DTO, and this will be used by when we'll be dealing with the database. So let's see one of the bean. For example, pizza bean. We have these three properties: pizza ID, pizza name, and price. These are the data members basically of this class. It is a plain Java class. And then we have some getter and setter methods. And finally, we have toString, which is we are overriding. So even if this code is not implemented, most probably it will be implemented. However, if it's not there, you can right click, source, generate getter and setter methods for all variables. Okay. And then we can generate toString as well for selected. Okay. So yeah, now we are good to go. Correct. This was pizza bean. Then we have pizza order bean. Oh, what is this? So this is to do item, and similar to this, we'll be having multiple to dos to complete in this whole implementation. There are around 27 tasks which we have to do, and I have a list of all the tasks ready and the flow how it needs to be done. So we'll be starting with to do 1.1 and we'll stop at to do 1.27, I believe. So before understanding this to do, let's try to understand what this a normal bean is. We have some data members, their getters and setters, and toString method, same as pizza bean. Then we have build range where we have from price and to price, and then we have getter setter, and yeah, that's all. So I guess that's what they asked over here. Then they are asking for DAO layer. DAO is data access object. So we have to create a DAO layer where we have to create pizza DAO wrapper class and interface as pizza DAO and pizza order DAO. So these two needs to be an interface, and then we have a wrapper class. As per the class diagram given below, provide the required annotations in the interface to enable Spring JPA data. Okay, now we have to provide some annotations to enable Spring JPA data, correct? So we have two interfaces, Pizza DAO and Pizza Order DAO, and they are linked to with Pizza DAO wrapper. So let's see how it goes. So in DAO, we have pizza DAO.java, in which we have another to do. However, let's try to understand what we have over here is repository definition, ID class, integer class, something, something. Then we have a transaction manager over here, and then a function named as find all pizza details. And since there is no body of this function, it is an abstract function. So since this is interface and not class, we'll be just declaring function over here and then write its definition in the class which is implementing it. So as you can see in the pizza DAO wrapper, it is implementing both of them. Since this is the repository class, even pizza order DAO is an interface and there is no function over here, but there is to do. So we'll try to understand that. Okay. Now, following methods needs to be created in pizza DAO using orm.xml and Spring GPA data. Cool. We have to do something now. And these are the things which we have to do. And there will be multiple tasks when we'll continue. So before starting to understand how the code base looks like, what are the activities that we have to implement over there, it is very important to understand the flow of program, how the communication is taking place in between whatever we are writing, what is the overall architectural level of understanding, and how the flow is there. So initially we have a client over here. In this, it is Postman client which is written. However, in our project, we have a web page. So in the dense pizza, we have two hyperlinks on the landing page. So whenever we do any operation, when we click on button or when we submit a form or whatever, it gives a request, and request is in HTTP request. So there are multiple methods: get, post, put, delete. So we usually deal with get and post methods, and whatever request type is, it is handled by the controller. So whenever you give any request, it will be given to the controller. Now controller will decide that this request is for what page and what is the endpoint which they are trying to call. So in this case, in our controller, we have these four endpoints, which is load pizza order, save pizza order, load bill range report, and fetch records within the date range. So as you would have observed in the beginning when we went through the whole implementation of the project, how it is working, we know that within the date range, it is trying to fetch the record and all. So these are the different endpoints available in our project. Now, whenever any request comes, it checks that what is the for which endpoint that request is and what type of request it is, and accordingly it proceeds with it. So this functionality is handled by the controller. Now, after this, the controller will go to that particular endpoint. Now, that endpoint, whenever it will reach to that endpoint, there is some service, some business logic, some operation, some calculation, something is there which we have to do, correct? Now, that operation is done in the service layer. So it will go to the controller, controller will pass it to the service layer. However, in the service layer only understand the bean structure. Okay. And now for our example, where we are trying to create, we have an option of creating a bill. So when we place an order, it creates a bill. So this bill is not in our database. Then how it is displayed on the web page? So all the business logic is written in the service layer, and this calculation steps, checking for exception if it is, and whatever is there is written in the service layer. So we usually follow architecture, a structure, a modular structure, where we first create an interface, which is service, and then we implement that interface, including that methods, and then write our logic. So that you will find in the code base that we have service and then service implementation. The most important thing which we have to keep in mind over here is it only understands bean. Moving towards the DAO layer, the DAO layer is the one which is responsible to deal with the database. So whatever you want to store in database or fetch from database is something which will be handled by the DAO layer. Now, what is the most important part over here is DAO layer only understand entity. Service layer was understanding bean. DAO layer is understanding entity. Now, since both the layers are understanding different things, we have a DAO wrapper class. And the main functionality of a DAO wrapper class is of converting bean to entity or entity to bean. So this is something which we have to keep in mind. Once we'll be understanding the code and the flow, it will get more clear. So DAO understands entity. Now, when service gives its bean to DAO, DAO will first convert that bean to entity and then store it in the database. And then, if it is fetching it from the database, it will be fetched as an entity only. Now, when it has to pass it to a service layer, since we know service only understands bean, it has to convert entity to bean so that service will understand it. And this is done by the DAO wrapper class. Next, we have database. So we already discussed that this is the database in my MySQL, and these are the records. So the overall flow was we have a client which will give a request to a particular endpoint. These are the methods which can be there. Controller will handle that request, whatever endpoint is there. It will try to give it if it doesn't require any service or data from the database. Otherwise, it will call that service method of from service. Service only understand a business logic. Okay, let's go back. So this is the client. It will give an API endpoint call. It will go to the service. Service only understand bean. We have a business logic in our service class. Then service will call DAO, and DAO understands entity. So it will first convert it into the entity if they want to store in database or retrieve or whatever. So it has to understand in the entity format. So it will convert, try to understand. So whatever deal is with the database, so it will be handled by DAO. And then we have our database. So this is how the communication take place. Okay. So whatever we discussed till now was good and it was important. However, what we'll be discussing from now onwards is the most important thing, because from now onwards we'll be doing the to-do task which will be required while you'll be doing your hands-on. So starting with the first to-do task, which is in orm.xml. So let's open that file and you can see we have to-do item 1.1 over here. What it asks is define JPQL query. So JPQL stands for Java Persistence Query Language. So we all know about SQL query language. However, it is dependent upon whether you are using MySQL or MongoDB or another database platform. So it varies. However, JPQL is a query which will remain constant no matter what type of database you will be using. Now, what we have to do by using JPQL is we have to define a valid JPQL query to fetch all price details. Okay, so let's go and code it. So the property which we'll be using over here, since we are writing it in XML file, we'll be using a tag which is named as named query. Control Shift named query. Okay, and the name will be pizza dot query one find all, whatever name you want to give. So this is the name, and then we are writing our query in query tag. Yeah, and we are good to go. So in the named query, where the name is pizza dot query one find all pizza details. So whenever someone will try to call this, they can get all pizza entity. So we have to read it as select K from pizza entity, where for pizza entity we are using K as an alias. So it will select all the table from pizza entity. Now, what is pizza entity? As we already discussed this is the pizza entity where we have pizza ID, name, and price. So that is what we are fetching over here. So till now in orm.xml, we defined a JPQL query to fetch all pizza details, which was a standardized query format used by JPA to interact with our database. Now we'll be referencing it later from our pizza DAO. Now to move our next to do, we'll go in DAO layer, where in DAO layer we have pizza DAO, and in this you can see there is our next task, which is 1.2. The task is this method should retrieve all pizza details and annotate the method with @query to use JPQL query defined in the orm.xml over here. So what it is asking for is to retrieve all the pizza details. What query we wrote in orm.xml was same, correct? It was retrieving all pizza details only. So that's what we have to do over here. And the code will be simple. They already mentioned in the comment that we have to use @query tag. But since when you will be using @query tag, you should know that you have to pass name over here. So when you say @query, you have to pass name over here. There should be some name. And the name which you wrote over there needs to be same over here. So in orm.xml, our name was pizza query, find all pizza details. So that's the same name which we'll write over here. Now our next to do task is in pizza order DAO. So you can see to do task item 1.3 over here. So it asks we have to define a custom repository for managing pizza orders. So the first thing is use custom repository. Now to use custom repository, we have an annotation named as repository definition. So let's use that. Rep R capital repository control shift. Okay, so you can see as repository definition, correct. And then since it is a custom repository, we have to define an ID class and then domain class. So let's define that. ID class is equals to, since ID will be integer dot class, And our domain class will be pizza order entity, since that's what we are using, correct? Pizza order entity. Okay, let's write it down. Dot class, since it's a class. So that's how we define our custom repository. And now what we have to do is add a method to save pizza order details in that database. So we will be using pizza order entity, and we will save this as a pizza order entity and our entity. Cool. Yep. So we did whatever they asked. So this is the annotation repository definition, not this repository one. We'll remove this. And in this repository definition, we have to mention our ID class and domain class. Since our ID will be from integer class, it's an integer, hence integer class, and our domain class will be pizza order entity. So let me show you pizza order entity. This is where we are storing our pizza orders. So that's why order now will be using this pizza order entity dot class, and then we are saving it in our database by using save method. Okay. Now our next to do will be in pizza dow wrapper class, where we have to do 1.4, which is saying this method should retrieve all pizza details. Note, this requirement needs to be implemented using Spring JPA data. Next, first to do is invoke find all pizza details method of PizzaDAO to get details of pizza. So this is PizzaDAO. This is the method find all pizza details. We have to invoke this method. Okay, so that's our first task. Okay, so in this to do 1.4, we have to first invoke find all pizza detail methods from pizza DAO to get details of pizza, and then we have to convert all pizza entities to pizza beans. So as you can see, this method is returning list of pizza beans. So let's first create some list of pizza beans. So copy this, paste here. List pizza bean, let's name it as list equals to new array list. Okay, of type pizza bean. Fair, semicolon. So we just created a list, and now whatever list we created is of type bean. However, from DAO we'll be getting entity. So we will create another list. Let's copy this one. However, this will be entity and not bean. And let's write list entity, new array list of type pizza entity. All good? Yes. However, we don't have to create this new array list. We'll be getting this by the function find all pizza details. But that function is a part of, as mentioned over here, pizza DAO. So we'll have to use this pizza DAO object which we created, which was already present in this code. So we will use this object over here and call one of its method called as find all pizza details, which will be passing list of entities. Correct. Cool. We are good now. And let's proceed further. So now we have a list of entities. However, we need list of beans. So we can iterate all the entities by using for loop. Let's say for pizza entity, with small pizza entity equals to, oh, or maybe colon, since we are using for enhanced for loop, from list of entities, and then we have to convert it into a pizza bean. Uh, Now we have a function over here, convert. Oh, where am I writing? Convert. So you can see convert entity to bean and convert bean to entity. This is what we do in wrapper class. So since right now we are trying to convert entity to bean, we'll select the first one and convert entity to bean, and we'll pass pizza entity over here, and that's all. Then whatever we get, we will add it in list. So list dot add pizza bean, and done. Now after it, it will return a list. Correct. Yeah, that's all. And now let's proceed further. That's what they asked. Invoke this, convert all pizza entities to pizza beans, and then return the list of pizza beans. So this is the list of pizza beans, as you can see here. Now next to do is in this file only, which is 1.5. This method should add pizza order details to database. And for that we have to convert pizza order bean to pizza entity. So what we did is we converted entity to bean, and now we have to convert bean to entity and then invoke the save method of the pizza order DAO interface to persist the order, convert the save pizza entity back to pizza on order bean. So we have to again convert from entity to bean and then return the detail of the newly added pizza order bean. So it's not easy at all. I mean, so much of conversion, correct? So what we have is add pizza order detail function over here, which is taking pizza order bean as a parameter. It is throwing an exception. Okay. Now let's proceed. Since we are getting pizza order bean, so let's create a reference and an object of each. So we are getting pizza order bean, and pizza. Let's assign it as null as of now. I hope I didn't use same name anywhere, since for the safe side, let's let use ret. Then we have pizza order entity, and so we can create an pizza order entity, since we have to convert first bean to entity, and we can write pizza order entity, and for naming convention red equals to, oh, no need of red, I believe, equal to. Now we have to convert. Before we converted entity to bean, now we will convert bean to entity, and we'll pass pizza order bean, I believe. Correct. Now it is showing an error. The method and the type pizza order is not applicable for the arguments pizza order bean. Oh, we are trying to convert pizza bean. No, no, no. We are trying to convert pizza order bean. So it's the wrong method. Let's use convert pizza order bean somewhere. Yeah, convert pizza order bean to entity. And then we are passing pizza order bean over here. Now it's perfect. Now, since we have to convert, now let's use pizza order bean object and convert again pizza order entity to bean. So we'll be using this as equals to, we will first convert pizza order. We converted bean to entity. Now we'll convert entity to bean. Okay, first one with pizza order entity inside. Correct. However, we are not directly converting this. We will be pizza order entity to bean, and then we'll pass this pizza order dow and call save method by passing pizza order entity. So once it will save, it will be saved in the database, and whatever we'll get as an entity, will convert that entity to bean and will pass it to this. And then finally, we will pass it to the return function. Pizza order this return. Done. That's what they asked. Convert pizza order bean to pizza order entity. Convert pizza order bean to pizza order entity. And then invoke the save method of the pizza order DAO interface to persist the order. Save method. Now convert the save pizza order entity back to the pizza order bean. Again, we converted it back to the pizza order bean, and now we have to return this. Hence, we used RAT in the end. Return the detail of the newly added pizza order bean. Returning it. Okay. So that was task 1.5. Let's move towards task 1.6 in this file, which says that this method should retrieve price from a given pizza. So to do is invoke the appropriate method using entity manager to fetch pizza details by using pizza ID. Let's zoom again and then retrieve the price of the pizza and return it. So the name of method is get pizza price, and it is taking pizza ID as a parameter, and we have to return price of it. Okay. So first of all, what we are getting is pizza ID over here, and we have to return price. So let's create price over here, which will be double. Oh, spelling mistake. Cool. Or we can assign it to 0, and then we can proceed as, since we are getting pizza ID, we have to create entity. So we'll use pizza entity equals to, first we have to create object, which is equals to entity manager dot. We have a find method in this, which will be finding with your ID whatever you will give and in which class you want to find. So we have to find it in pizza class, pizza entity class, I believe. dot class. So in this class, you have to find with pizza ID, correct? Next is if pizza entity is not equal to null, that means we found it. So we'll write over here that if we are trying to get pizza entity and if it's not equal to null, it means we have it. So what we'll do is we will calculate the price or get the price from it. So the price equals to, we have pizza entity, correct? So by using that, we have a method get price, which we already declared while creating this entity, while creating getters and setters over there. So now we are getting the price of it, and now when we'll be returning, we'll use return price. So that's how the implementation of this to do is. They asked for invoke the appropriate method using entity manager. So we know in the entity manager we have one method named as find, which takes entity or class in which you have to find and the ID of what ID for which you have to find, and then it fetch the detail by using the pizza ID, and it retrieve the price of the pizza and return it. So if we find the entity, we retrieve the price of it and then return the price. Done. Now let's start with the next to-do item, which is 1.7. It is this method should fetch all order details between the given bill amount range. Note, this requirements needs to be implemented using JPA Entity Manager. Okay. Now we have different to-dos. The very first is we have to write a valid JPQL query to fetch all the pizza order between the specified bill amount range. Now, if you know SQL queries, then it is very easy for us to write a JPQL query. I'll be writing one JPQL query over here, and then you'll understand and you can relate it with the SQL queries as well. So, when we have to write a query, before writing the query, let's first understand this is the method get order details. This method is returning a list of pizza order bin, correct? This is what is asked. It have two parameter from bill to bill. So these are the two ranges which we have, and everything is good, I believe. Now, since it is returning a list of order bean, let's create this list first. Let's list of pizza order bean. Um, list of pizza order bean. So this is the reference which we created, assigning it as null as of now. Moving further, now, as I was saying, I'll write a query and the query will be in JPQL format, but similar to SQL query. So when we write query, we use query from Java persistence, JavaX persistence, and then query. This is reference of it or the variable which will be storing the result of a query, which is equals to entity manager. It is mentioned over here we have to use JPA entity manager. So we'll be using that entity manager dot. There is a method of entity manager which is create query. So we'll call that method create query, and in this we have to pass our query. So let's write the query. So the query is what we have to do is select something from the pizza order entity where the range should be from minimum to the maximum, which is there. So let's write it select K from what is the table name? Pizza. We can copy it from here. It is pizza order entity. and alias sk. O should be capital, naming convention, where k dot. Now, in this pizza ordered entity, we'll be having a bill. So bill greater than equal to. Now we don't know the value. Value will be given as a parameter. So we'll write a question mark over here with an index so that we'll set it afterwards. Value equals to question mark 1 and k dot bill is less than equal to again question mark 2. Query is completed. Now what we have to do is our query is ready. Now we have to set these parameters 1 and 2. So we'll say query dot. There is a method called as set parameter. It will take first as an index or whatever key we gave over there, and the next will be the value. So we know first value is from bill. So let's paste it here. Similarly for the second one, only we have to change index and to bill. Done. So now our query is ready with the parameters set. Now, whenever we'll be getting a result from this query, since it is getting result from the database, it will be in the entity format. Correct? Pizza order entity format. So let's create a list of pizza order entity and we can name it as list pizza order entity, which is equals to whatever result we get from query. Query dot. So there is a method get result list. We'll be calling that method and we'll get our result, which will be stored over here. Okay. Now the next thing is, since we already got it in an entity format, we have to create it into a bean format. Otherwise, we can't pass it to the UI layer. So before converting, let's try to create this pizza order bean as an array list is equals to new array list of pizza order bean type, correct? Next, we can use for loop to convert each entity to a bean. So for pizza order entity, the variable can be entity from list of pizza order entity which we have over here. And then we can convert it to a pizza order bean. Now to convert it, we have a method named as convert entity to bean. So we are converting pizza order entity to bean and passing entity over here. Now it will convert it into a bean. Once it is converted, we will add it into our list. So list, which we created over here, dot add pizza order bean. Done. Now our list is ready and we are passing list of order beans only. So we can pass it over here. Done. Our function is implemented. So this was to do 1.7. What we did is we have to first write a JPQL query to find it specifically. So this was the JPQL query. Similarly, we have a SQL query where we write select star from pizza order entity and alias whatever we want to give, where alias dot whatever column name is there, it should be greater than equal to some value and it should be less than. So this is the condition. So this is how we write in the SQL as well. And this one is a JPQL query. Then we are setting it from whatever we are getting as an argument, we are setting over here. And then what result we get as a get result list, it will be in the form of entity. So we stored each entity in our list as a list format. Then we try to iterate each list over here and converted it into a bean, and then added it into a list of pizza order beans and then passed it over there. So this will be passing it, correct? Okay, so we completed our to do 1.7 as well. Our next to do task is in the service layer, but before moving towards there, let's first revise all the tasks which we did. So we started with orm.xml where we wrote a GPQL query. Then our next task was in pizza order DAO, in which we created it as a custom repository, and then yeah, then we used a save method of to save it, to save the entity in the database. So these are the three tasks. Then we moved towards DAO wrapper class, where there was 1.4 in which we implemented this find all pizza details. So first thing, in orm.xml, we wrote a JPQL query, which we used in Pizza DAO, and then we used Pizza Order DAO. So both of these are repository. Pizza DAO and Pizza Order DAO are repository. So you can see over here in the Pizza DAO as well, we have a repository definition. So these are dealing with the database. However, since we discussed that entity and bean, so DAO layer understands entity, however, service layer understands bean. So we went to DAO wrapper class where we are trying to convert bean to entity, entity to bean, and all the relations which we wrote. So from the pizza DAO only, we are using that function, but we are just converting it. So this is acting as a middleware communication. And then we implemented 1.5 in which we had add pizza order detail. Then 1.6, it was retrieving a price from the given pizza by using get price method. And then in 1.7 we had we used JPA entity manager, and by using that we created a query to fetch the details with a condition. So a condition was it should be greater than this amount and less than this amount. So this is what we wrote in DAO. Now for the next to do, we are moving towards the service in which we'll be writing a business logic. So our first to do is in pizza service implementation. As I already mentioned, we have a structure structure way of writing the code. So we first create an interface, write down methods over there. So this is just a method declaration. However, then we'll be creating an implementation of it by overwriting these methods. So coming in the pizza service implementation, where we have our next set of to-dos. So now let's begin with the first task in our service layer. The first task says that this method should fetch all pizza details. Now there are multiple subtasks. We'll try to understand each of them and write this method over here. So the first method is invoke the get order details method of pizza DAO wrapper class. So there is this class where this method is there. We have an object or a reference of this class, okay, and we have to invoke that method. It's easy, cool. But we have to store whatever data we'll get, correct? And as we are passing it as a pizza order bean, so let's create a reference of it. naming it as list, which is equals to. Now we have to call method of pizza dough wrapper. So taking reference of this object dot. Then the method is get order details. Now in this method we have to pass two values from bill and to bill. Done. Now this method will give us a list of pizza order beans and we will store it in the list. Next is return all pizza order details. So let's return it. Done. And the last is if no order exists within the given range, then throw a custom exception as no record found exception. Cool. So we have to check if the list which we are getting is null or not, or list dot size is not should not be zero. So if size is zero, then we have to throw an exception. So since we are throwing new exception, which is user defined, and let's write a message over here. So the message will be no record were found for the entered bill range. Done. So if size is a method, correct. So we are checking if the list is null or the list dot size is equals to zero. If that's the case, we'll be sending this or throwing this exception. Otherwise, we will return the list. So this is to do item 1.8. Now let's move towards to do item 1.9, which is this method should add pizza detail. Cool. And this is the method. It is returning pizza order bean. Okay. First is invoke get pizza price of pizza dough wrapper to get the price of the selected pizza. So which pizza is selected will get it from the pizza order bean. So we have to get price of it and we know the price is in double format. So let's use double price equals to. Now we have to call from pizza dough wrapper and we know that we have a reference of it over here. So let's use it dot. And which method we'll be using? Get pizza price. If you remember, we declared this method. So get pizza price. And now for which pizza, what is the idea of that pizza for which we have to get a price? So we will use this bean, which we are getting as an argument. And from this bean, we will get its ID. So we have get pizza ID as a function. And once we get it, we will extract that pizza ID, and for that pizza ID we'll get that price. So we have a get price which is taking ID as a parameter and giving a price which we are storing in this price variable. Cool. Now once it is done, what we have to do is we have to generate a bill. So we'll be giving them a bill, correct? So now let's use double. Okay. Okay, so now we fetched the price. However, whenever they add a pizza order, we have to show them the uh, final bill as well. So let's calculate that bill. Double bill is equals to. So for calculating the bill, we require two things. First is what are the number of pieces they ordered. So let's fetch it from the pizza order bean dot get number of pieces. This is the method, and then we'll be multiplying this number of pieces into the price which we can just fetched. Done. Now we have to set this. So we have this pizza order bean, and we have to set this bill amount pizza order bean dot set bill, the getters and setters which we created, and then we are setting bill over here. Now what it is returning, it should return a pizza order bean, correct? So um, we have a pizza. Let's read this. Calculate the total bill using the unit price and the number of pieces ordered. So we calculated the bill, then set the calculated bill value for order bean. We set the value over here. Then invoke the add pizza order details of pizza dough wrapper and return the pizza order bean as an object. Okay. Now we have to return a pizza order bean object, correct? So when we'll be adding it by using a pizza dough wrapper, which is here, let's add it. So in the pizza dough wrapper, we have add pizza method, add pizza order detail, and then we are passing pizza order bean, which is this. And then after passing this, whatever result we'll be getting is simply pizza order bean object, which we are returning. So this is the implementation of to do 1.9. Okay, going through it again. Invoke the get pizza price of pizza dough wrapper. So this is get pizza price. Sorry, this one of pizza dough wrapper to get the price of the selected pizza. So to get the selected pizza, we need pizza ID, which we are fetching from the pizza order bean, which is an argument which we got. And then we are calculating the bill, setting the bill to that particular bean, and then we are storing it. So pizza dough wrapper dot add pizza order details, and then whatever we'll be getting as a pizza order bean, an object, we are returning that object over here. So this was to do 1.9. Now let's move towards to do 1.10, which says that this method should find all the pizza details. Okay, so the steps are, first we have to invoke the find all pizza details of pizza dough wrapper to get all pizza details. No problem. But when we will be invoking that method, it will return something, correct? So let's see what it is returning. Um, we have a pizza dough wrapper over here. Let's take it. Dot, we are calling a method find all pizza details, and let's try to understand what it is returning. So let's go to the implementation of this method, and we can see that this method is returning a list of pizza bean. Okay, going back towards there. So if it is returning a list of pizza bean, let's store it in a list of pizza bean only. So list of pizza bean named as list is equals to whatever we will get as a result from this. Okay. Now, once we stored this, we have to map it, since we have to return it as a map integer and string. So we have to create a map for it. So let's create it, map of integer and string. Let's name it as pizza map equals to. So we'll create a new hash map of type integer and string, and done. Now our pizza map is ready. Our pizza list is ready. Now let's start mapping it. So we'll be using for loop where we'll be iterating for pizza bean that we have. And from that pizza bean, we'll take each as an item from pizza list. So whatever pizza list will have, okay, let's name it as pizza list over here for better understanding. Okay, so this pizza list is from this pizza list we are iterating each as an item of type pizza bean, and then we'll be mapping it. So what we'll do is pizza map dot, we have a method called as put, and then we have to give key value pair. So let's give pizza id as a key and pizza name as a value. So we have item dot get pizza id, and then we have item dot get pizza name. So this is how we are giving key and value over here. Done. Now what this is returning, it should return this map, correct? So the name of map is pizza map. Let's return it. That's all. This is our to-do task 1.10. So we completed all the to-dos in the service as well. Now our next task is in the controller. So you can see we have a package over here, com.accenture.lkm.controller. So all the controllers are in this package. We have different package for everything, for bean, controller, DAO, service, entity, exception, resources, everything. So now let's discuss about this controller. So we opened the pizza order controller.java, and now let's try to understand what is the function of it. So this Spring MVC pizza order controller class is responsible for managing HTTP requests related to creating and saving pizza orders. It display a list of available pizza and handling errors as well. So let's understand and break down each part in detail. So as you can see, there is an annotation over here which is at the red controller. It says that this is the class as a Spring MVC controller, allowing it to handle HTTP requests mapped to it. Then this is the name of the class. We are auto wiring pizza service over here. So it will inject an instance of pizza service into this controller. So the pizza service is the service layer that contains the business logic which we already implemented before. Now, next is this request mapping. So this request mapping is used when we have to map a request to a particular endpoint. So over here, we have this endpoint. So whenever anyone will try to hit this endpoint, so we are writing value, then endpoint over here with the method as we discussed. In HTTP, we have get, put, post, delete. So whenever anyone will try to hit this endpoint with the method get, so this request mapping is mapping over here. So when once it is done, we'll be doing this thing. So this is how we read it. Then we are creating a model and view. So what it does is it creates an object that contains the view name and model data to be passed to the view. So which view is, we have pizza order. So we are setting the view name as pizza order. Where can we find this pizza order? You can see over here we have JSP views, and in this we have this pizza order.jsp. Let's open it. Okay, so this is our view. We have another to do even in this. We'll be coming back to it. And now let's go back to our controller.java. So it is setting the view name as pizza order. So it will open this pizza order.jsp, and then it is setting an object over here. So the first task which we did is it specifies that PizzaOrder.jsp is the view and it will display it. And the next thing is it adds an empty pizza order bean object to the model under the key name pizza order object. So this is just a key, and then it is creating a new object of pizza order bean which will be mapped to this particular form. So whatever entry a user will write will be mapped to this key, a new object which we created, and then it will be stored. So the object of the model and the key, this pizza order object. So the form can be bound to this object. The only purpose is to load an empty pizza order form, then bound it to the pizza order object for the user to fill it out. Clear? Then it will return this model and view. Now let's try to understand our to-do task 1.11. So we completed 10 tasks and this is 11th. It asks for this method should save the details of the pizza order bin. So this is the description. Cool. Very first task which we have to do is map the URL to the save pizza order. So what is this? This is an endpoint. So how we map the URL to an endpoint? We use request mapping. So let's use this one and update it according to our requirement. So we have to map it to this endpoint. So let's write it over here. Done. And then the method will be, let's say, did they mention the method? Okay, retrieve the pizza order and do this is this. Okay, let's see. Let's keep it as get only and then we'll decide what to do with it. Then what we are doing is next is retrieve the pizza order being submitted by the view. So, oh, if we are retrieving this pizza order bean, so it means the method is post. Then only they can send something as a parameter. Okay, so we have this model and view. This is our function name, and then in the model attribute. So what we are getting with when they are hitting this API endpoint, so we are getting this object, pizza order object, which we created above. So now when we'll be getting this object, it will have the details which user filled in that form. And then we are binding the result and done. So we got to know that it is a post method. Now the next thing is they are asking, okay, retrieve the pizza order being submitted by the view. So to retrieve it, let's create another model and view. Oh, I have to name it is equals to new model and view. Done. Hmm. We'll be discussing this annotation valid later on. And then we have this annotation model attribute, which we discussed. It binds the form data to the pizza order object of type pizza order bean and provides it to the method. Now we have a binding result. So binding result captures any validation error if binding after binding and validation have occurred. So that's how it is. Then we have a validation check. So we can have it here if they'll ask. Okay, so if validation fails, populate a model and view with the pizza order as the logical view and all. Okay, so they are saying perform a validation check. Now, how to perform a validation check? So what we can do is we have a binding result, correct? So in this binding result, if there is any error, we'll get to know about it. So I'll tell you how to write it. If we have this binding result dot, we have a has error method. So if binding result has error, then what we have to do is, if the validation fails, populate a model and view object with a pizza order. So we will populate the model and view which we created here, and we will set view name as pizza and order as mentioned above. Pizza order. Then, so if validation fails, populate a model and view object with a pizza order as the logical view to display error message. Fair. Next, if what if it pass? So on successful form validation, so let's create else statement over here. What we have to do is it should invoke the add pizza order detail method of pizza service. Okay. Now, when we'll be invoking that method of pizza service, let's use this. So, do we have a reference of it? Mm, let's see above. Okay, this is the reference, and we have to invoke the method named as add pizza order details, and then we have to pass pizza order pin. Correct. Now, what we will do is, since we are passing pizza order bean, let's see what it will return. So let's go to the implementation of it. Oh, this is service. We have to see service implementation, and we are calling this method, which will be returning pizza order bean. So add pizza order details, correct? Correct. So now we have to save it, correct? So how we'll save it? We will um, create a reference of it. So we have to return it, hence we'll write return of this equals to whatever we get as a result from this. Correct. Now what else do we have to do? Uh, is this done? Add this method of pizza service. Okay. Then create and populate a model and view with this. So let's do this. So it will be inside else only. We have model and view. We will set view name as pizza order success as mentioned above. Then we have to set add object as well. So as the logical view and add an appropriate message along with the order ID and bill. So along with order ID and bill. Let's try to add object in this model and view dot add object, and we'll type a message over here. So message will be key which they'll be using to extract it, and let's write down the message here. So the message is hi, and so since we are writing up appropriate message, let's write this message over here. Now in the else part, we first called this method. This method is returning pizza order bean. So we created a reference of it, and this reference will have this bean, and then by using this we can extract the customer name and its order ID, and accordingly we can say that this is the bill amount which we are extracting from it only. So this is the appropriate message which will be displaying. So the message is hi, the name of the customer, your order is placed with the order ID, then we are retrieving the order ID, and the bill to be paid is, then we are retrieving the get bill amount. Now, um, since we already saw the implementation of this, that once we click on submit, it gives us this message, appropriate message. So this is what we did. Now the next is we have to return model and view, correct? So let's return our model and view, and done. This is the implementation of to do task 1.11. So let's try to understand it again. First is map the URL with the save pizza order. This is the endpoint. Then we understood that since it is getting a model attribute which we set above, so this is the post method where they are trying to send something to us. So the method is post, then retrieve the pizza order being submitted by the view and perform validation check. So this valid attribute will perform the validation check, and even we did a validation check over here that if binding result dot has error, this is the method of binding result which we have over here. If the error is there, we will set the view. So if validation fails, set the model and view as pizza order. That's what we did. And then on successful form validation, it should invoke add pizza order details. So else part, it is invoking add pizza order detail method of a pizza service over here, and then create and populate a model and view. So we are again setting it with this as a view, and then appropriate message as an object to the model and view, and then we are returning that model and view. Now let's try to understand our next task, which is task 1.12. It says that this method should be executed before any handler method of this controller. So to do this, what we have is one important annotation, which is at the rate model attribute annotation. So we'll be using this annotation over here, and we will name that annotation with something. So since this is the method, if we use this method at is if we use this annotation at a method level, it will be executed before any handler method of this controller. So what it will do is it will define this method as a model attribute provider, which means it will be executed before any handler method of this controller. And this is the name. So this will create a model with this name and attach this attribute, and whatever we will be getting or fetching from this method will be attached over here. So the next thing is, and it should populate pizza name dynamically in the form. So the first is it should invoke find all pizza details of pizza service. So to invoke that, what we will do is we have a pizza service reference here. Let's use that reference dot. What we have to call is find all pizza details. And then we will be returning this. Return a map containing pizza ID and pizza name. So it will return it. So let's go to this implementation. Since this is returning map only, we don't have to convert it into anything else. Okay. Now we understood two things. The very first is if we use at the rate model attribute at the method level, this method should be executed before any handler method of this controller. Next is we are returning this by calling this method. That's all. So this was to do item 1.12. Now let's proceed towards the to do item 1.13. It says that this method should handle common exceptions. So whatever common exceptions arises, we have to handle it over here. Now there are multiple subtasks. Very first is annotate this method with appropriate annotation to indicate that this will be handling exceptions. Now what is the annotation for it? Let's write it over here. The annotation is at the rate exception handler. So this will say that this is the method which will be handling all the exceptions, and then we have to pass a value as exception class dot class. Done. So this will make sure that exception handler, this annotation marks this method as a handler for all exceptions of exception dot class, capturing any unhandled exception thrown within this controller. Now, what is the next task which we have to do is it should create a model and view object to render the view and populate the data. Okay, so let's create a model and view in this um, model and view with model and view is equals to new model and view. Done. Now we have to set a view name over here. So this is the view. We created a model and view, and it should set the view name to this. It is mentioned over here. Let's copy this. So we have to set for this model and view dot set view name method, and then we'll be setting this over here. Okay. So the view name is ready. This view will be responsible for displaying the error message to the user. Let's go to this view to see what is there. So they are writing that exception occurred in and whatever the message is. So, okay, this is our exception page basically. Let's go back to our controller. Next step is it should set the view name. It is done. It should add the exception message to the model and view object with a key named as message, and the message will be accessible in the view, this view where we are rendering for display. Okay. So now what we have to do is we have to attach an object over here. So let's add it. Use this model and view dot add object, and then we'll be writing a message over here. So this message will be used as a key, and its actual message will be this. So what we'll be giving a message is whatever exception which we are getting. So this is the exception. We have a method in this exception get message. So we'll use that. Now, whatever exception message we have, it will be passed as a key message and they can use it over there. So it should add the exception message done. Finally, it should return the populated model and view. So let's return this. Done. That's all. So this was to do item 1.13. So with this, we completed with our first controller, pizza order controller. Now let's move towards the next controller, which is report controller. Now, in this, we have to do task 1.17. Let's try to understand this. So, before implementing our to do, let's first try to understand this code base. So, again, this is a controller. We are auto wiring our pizza service and its reference. Then we have again one request mapping over here for load bill range report. So whenever there will be a request for this load bill range report, it will be redirected over here and this method will take care of it. Now, one question should arise that there is no method type over here. So by default, if there is no method type, it is a get method. Okay. So what it does is it is creating a model and view and with the name order report. So it specifies order report.jsp. Okay. So this is a controller. So before what we used to do is we first create a model and view. So let's remove this from here. And then what we do is we use this and view and then set view name. Correct. And then pass view name over here. Correct. This was our old implementation. However, if you don't want to do it in this way, then what you can do is you can pass your view name over here as well. as a constructor argument or whatever you want to say. So let's pass it there. So there is no need of this line now. What it will do, it will specify that order report.jsp as the view to display, which serves as the page where user can input a price range. So this JSP will be called, which is there, order report.jsp, and this page will be called. So let's go back to our report controller, and then we are adding an object with this key. And basically this will be the new bill range object, and then we are returning the view. Clear? So what we did is, first we did request mapping. Default method is get. Then as per the view, we set the view as order report.jsp. Then it adds an empty bill range bean object to the model with the key name bill range object. This object binds to the form order report.jsp for capturing the user input. And the purpose is simple. It initializes and loads the order report page where user can enter a price range for filtering pizza orders. So we already saw that in the implementation. Now let's start with the to-do item. So it says that this method should save the detail of pizza order bean. Okay. So the first is map the URL. So what was the annotation which we was you? So what was the annotation for mapping? We know it is request mapping. So let's copy this from here and try to map it here. Okay, for this endpoint, let's change the endpoint. Done. Now, what will be the method? Since it is getting that uh, this is a parameter, so we get parameter when the method is post. So let's write over here method equals to request method dot post. Done. So this was the URL mapping. Then we retrieved the bill range bean, which is here, submitted by the view, correct? And next, what we have to do is invoke the get order details method of the pizza service. Okay, so before proceeding, okay, let's try to see. We have this pizza service over here, and we have to invoke a method of it, which is get order details, correct? So let's see. It takes two parameters. So what are the two parameters that we have to pass? Um, so we have bill range over here, correct? So we have to get from price and uh, another is to price, I believe. So let's use this bill range dot get from price, and then again bill range dot get to price. So we are passing these two parameters to get order details. Now let's understand how this works. So this is normal pizza service. We'll go to pizza service implementation. We know we have get order details is there, add pizza order. Which function we are calling? We are calling get order details. Okay. So pizza service implementation, get order details. This takes from bill and to bill, and it returns a list. So let's have it. Report controller. It will be returning a list. So let's store this list over here. So the list will be of type pizza order bean, correct? And let's name this list as list of pizza order bean, which is equals to whatever we are receiving from this method. And now the next is create and populate a model and view with order report as a logical view and add list pizza order to it. Okay, so let's create a model and view. Model and view, model and view is equals to new model and view. So we created it and now we have to set a view name. So let's set so small this one dot set view name. And what is the view name? Order report. So let's paste it here. Done. The next is we have to add this list parameter, pizza order bean list as well over here. So it should be view name. And now let's add object. Add object. And in the object we'll be passing pizza order list, but this is the key by which we will be fetching it. And then this is where we have a view. Our list is this. So let's attach this. Done. So we are adding an object with this key and this is the value. Now let's return the view. Okay, create and populate model and view with this and then attach this and return. Done. So this was our to-do task 1.17. This method should save the details of pizza order bean. So what it is doing is it is first um, getting all the list, get order details from this bean which we have, and then according to that order detail, we are setting the view and then we are passing this object of list of order beans which we fetched. So it will fetch the records within the bill range. I guess this title is wrong. This method should save the details of pizza order bean, and it should be different. It should be like this method will fetch all the records within the bill range or something. So I believe there is a typo error over here. So let's correct it. Done. Cool. So we understood that we did a URL mapping. We know this is the post method. Then we had this bill range which we used to get price and from price and to price. And then we fetched the list. We are storing it in this list pizza order bean. Then we are passing it as an object with this key. So that's how we implemented this. Let's start with the next task, which is item 1.18. This method should handle no record found exception. So the first task is annotate the method with an appropriate annotation to indicate that it handles an exception. So what we learned is we have a specific annotation for exceptions, and what that annotation is, we can write at the exception handler. So since this is the method, we can say that this method is an at the exception handler. Correct? And now we have to give a value that for which type of exception. So value is for all the types of exception. So we'll take the parent class exception dot class. Now this method is an exception handler method. Next step which is given over here is it should create a model and view object to render view and populate the data. Okay, so let's try to create a model and view object. Mm, Model and view, copy, model and view is equals to new model and view. No, brackets. Cool. Now what we have to do is we created a model and view to populate the data. It should set the view name to this one. So let's try to set the view name, model and view dot set view name, and the name needs to be no record found exception. So let's see if we have this name or not. So this should be the JSP which will be called. So let's see this one. It have an exception and this will be called. Okay. So let's go back to our report controller.java. Second is done. Third is done. Fourth is it should add the exception message as well. So let's use model and view. Okay. Now we will add object and we will use key as message, and in this message we will be adding, since we have this exception and we know that this exception dot get message is a function over there, we can use that function and we'll be attaching this in the model and view. Okay, next is finally it should return the populated model and view. Let's return this. Done. So this was to do item 1.18. Now let's proceed with the to do item 1.19 and try to understand what it includes. So it says that this method should handle common exception. Okay. Now first is annotate the method with the appropriate annotation. So we'll be using same. Okay, they annotate this method with appropriate annotation to indicate it handles no record found exception. I guess we did a small mistake over here. Whatever we implemented above is used for general common exceptions. So let's copy it from here and paste it here. And then we can see that this is what we implemented right now. However, we have to change this one. So it won't accept normal exception. It will only accept uh, no record found exception. And then it will render it to this. So for this one, we will be rendering generalized exception, not this one. And then, so since it is clearly mentioned that it should only be called for this type of exception, so let's call this one only dot class, and then let's create a reference of that only. I guess now we are good to go. Cool. So this is also an exception handler, and that one is also an exception handler, but this is a general exception handler. However, this is specific to no record found exception handler, where we'll be setting view name as no record found exception. Otherwise, we'll be setting generalized exception handler page. I hope it's clear. So till now we discussed all the tasks which was there in our controller. Now for the next task, we have to go to bean layer, and specifically in bean, we have pizza order bean over here. So you can see we have one more task over here which says that use Spring MVC standard validation over here. Now we'll be learning how we'll be using the standard validation over here. So what are the different validations which they are asking for? First is ensure that pizza ID is a mandatory field. So this is our pizza ID and we have to make sure that this field is mandatory. So how we will do that is by using annotation. So we have one of the annotation which is not null. So we'll say that pizza ID can't be null, and if it is null, then you have to write down a message over there saying that please select a valid pizza. So if it's null, we have to write down a message over there by saying that if it's null, so we will be saying please select a valid pizza. Done. So this was the first task, ensure pizza ID is mandatory field. Then the next task is, okay, we don't need this semicolon since it is annotation. Next is validate customer name should have length between 3 and 30. Okay, so we have a customer name over here. We have to validate this. So the minimum count is 3, maximum is 30. So there is one more annotation which is at the rate size. Now in this size, we can say the min is equals to what is 3, comma max equals to 30, comma if it's not as per the criteria, we'll have to write down a message over here. So the message equals to, we'll be writing customer name should have length between 3 and 30. Between 3 and 30, I'm sorry. Done. So at the rate size, minimum 3, maximum 30, and the message. Done. Second is done. Third is validate contact number length should be 10. It should be exactly 10. So this is contact number. We can say that size is equals to min equals to 10, max equals to 10, and then message. What is the message? The contact number should have length 10. Done. Next is ensure number of pieces ordered is a mandatory field with a minimum quantity 1. Okay, so this is the number of field. We have to make it first um, compulsory field. So what we used is not null. And then let's first use that not null, and the message can be quantity should not be empty. Done. And next thing is we have to use one more annotation by saying that minimum quantity is 1. So we will be using at the rate min. We have a min as well. And then we will specify that value is minimum value we can specify over here. Value is 1 and the message is minimum value for the quantity is 1. Oh, inverted commas. Done. Okay. So we did all the to-dos which was mentioned over here. So we learned three different annotations today. First is not null, second is size, third is min. Okay, that's all in this one. Now our next task is in JSP files. So let's go to the JSP files. We have this JSP view folder over here. In this, we have PizzaOrder.jsp over here. So we can see the to-do is complete the PizzaOrder.jsp page using Spring MVC form tag library. Okay. So what we have to do first is create a text box to input customer name field. Okay, so this is the structure which is ready. We have customer name over here. We have a form tag over here, and model attribute is there, method is there. We have to create a text box to input customer name field. So this is customer name, and for this we have to create a text box. Since we are using MVC form tag library, we'll continue with that only. So we have form colon, then we have to use, since we are taking input, it will be input, and the path will be customer name. Okay. The next thing they're asking is create a text box for input of contact number. So this is the customer number. Let's create a form tag over here, and we'll be taking input, and the path will be um, contact number. Done. Next is create a drop down list to populate pizza name dynamically. So this is pizza name, this is table data, and we have to create a dynamic this drop down. So we have a form tag in which we have a select tag. Now in this form select, we have to give first path, which will be pizza ID, and then we can write down our form options. Since we don't have hard-coded form options, we have to make it dynamic. We will use form options of form, and the value will not be assigning values directly over here. So we'll keep it empty and we'll assign label, which will be select. Okay. Now, what are the options that we are providing? This was option. Now I'll be creating another form tag, which is options. This is the dynamic one. So let's include this, and both option and options both are auto close tags, so it's okay however you want to write. And the items will be not item labels, items. Uh, so the items is equals to what we can write here. We have pizza name and ID. If you remember, I'll use dollar sign. Now let me remind you where we did this. So we had this pizza name and ID somewhere. Okay, so you can see over here in the pizza order controller, we have a model attribute named as pizza name and ID. So this is what we set. We are setting it while as a model attribute. So you can use it over here in your JSP file. So in this pizza order.jsp, we are using that same thing over here, pizza names and ID. So that's how these items will be, these options are dynamic over here. So we created a drop down list to populate pizza name dynamically. Then we have to create a text box to input number of pizza to order as quantity. Okay, so this is quantity. We have to input a text box over here. So we have a form. In this form, we have input, and the path will be number of pieces ordered, and yeah, that's all. So we did this, create a text box of input of number of pizzas, order as a quantity, and then display form validation errors if any. Okay, so then next is create a submit button. Cool. So let's see how we'll be adding it. So we have a has bind errors if you remember in Spring. So what we'll do is first we'll add our input button over here. No, I mean submit button. So it's in input only. Input type is equals to submit, and value will be order. So when they'll click on order, which will be a submit button, it will redirect to, there should be a form action over here. Action is this page context dot request dot context path. Okay, so that's what we are getting over here. And then index.jsp. So it will get redirected to save pizza order.html once we click on this. Now, how to check for the errors? After this home tag, we'll be using Spring has binder errors. So in Spring, we have has binder errors where the name will be pizza order object. So while binding this object, do we have some error or not? That's what we are asking basically. And if we have any error, what we'll do is we'll use an h3 tag to print all errors, and then we'll print all the errors. So in the form tag itself, we have error tag, and in this we can specify path, which will be all. So whatever type of error it is, and the CSS class will be error class. Done. So even this is self-closing if you want to use it in this way. Then, so we used Spring has bind errors for this object. If it is there, we'll be printing all errors for all the path type and with CSS error. So it will be a red color. Done. So create a submit button. Done. Display form validation error if any. Done. So whatever task was there in this JSP, pizza order.jsp, we completed that. Now our next task is in pizza order success.jsp. We can see to do item 1.6 chain over here. We have to display a message showing order placed successfully. Note you can refer to do item 1.11. So let's see what we had in to do item 1.11. Um, So the item 1.11 is in pizza order controller. Let's go to pizza order controller. Item 1.11. This message method should save the detail of the pizza order bean. Okay. And if over here, if the validation fails, it will populate a model and view object with a pizza order as the logical view. So, okay, we are talking about pizza order success. So this one. So create and populate a model object view with a pizza order success as the logical view name and an appropriate message along with the order ID and bill. Oh, so what we are doing over here is we were setting this as a view name and then we were passing a object over here. Correct. If it is success, then our view name is this pizza order success, and then we are passing this object. So we'll be using this message over here to print success message. Now, how this works is um, we know that it was a key value pair, and we have add pizza order details here. Then after this, we can use an h3 tag by saying we'll be using a dollar curly brackets and message here. So this was the key which we set it over there. So whatever message was attached is attached with this key over here. Yeah, so we just have to print this message over here, which we were passing from here. What was the name? Pizza order controller. So this was the key which was holding this message. So this will print it in pizza order success.jsp when we'll be printing message by using dollar sign. Done. This was the easiest activity, I believe. Now the next activity is in 1.20, I believe, which is in order report.jsp. So let's see. In this order report.jsp, we have to complete the order report.jsp page using Spring MVC form tag library. Okay. Then we have to create a text box to input form price and to price. Oh, from price and to price field. So this is from price, this is to price. So we have a form tag here, and this we have an input tag. We have to specify a path, so we'll say form. Oh, it's from price, and then same for this one. Let's copy paste, and we'll name it as to price. Done. Next is create a submit button with the label fetch details. So let's add submit button here and put type is equals to submit, and value is equals to what they're saying fetch details. Done. Next is so the next task is whenever user clicks on the submit button, order details should be displayed on the same page. So we have a submit button over here and we are trying to fetch details. Correct. Now, when we will be clicking on the submit button, it will redirect to fetch records within bill range. Do you remember we wrote this somewhere? Let's go to report controller.java and we can see that we have this fetch records within bill range over here. And we are getting a post method for it. And what we'll be returning is a model and view. But the important point over here is in model and view, we are attaching an object with a key pizza order list, which will be having a list of pizza order beans. So this pizza order list is something which we can directly use right now. So let's go back to pizza order report. And once it will be, you know, going to this endpoint, it will return back with that pizza order list. and we can use it over here to display. So when user clicks the submit button, the order details should be displayed on the same page. So in this page only, we have to display this order details as well. Now check if the data is available before displaying it. So how we will check that? We have our submit button. After that, we'll write our condition over here that we know we have this core library of JSP. So we'll be using that core library and we'll be writing a condition over here. So let's directly paste the condition here and try to understand how it is working. Okay, so we have C if test is equals to not empty, then we have a table over here. We have to close this table as well. So let's close it. Done. And then we have to close this C if as well. Done. So we are saying that if test is not empty for this, then we'll be proceeding further. We created a table with a table row in which we have a table heading as order ID, customer name, pizza ID, bill, and quantity. Then for each pizza order list, since we are getting a list, we created an iterator, and then in table row, in the table data, we have a cout with a value of iterator.id, customer name, pizza ID, bill, and this will keep going on till the iterator continues, and then cout number of pieces ordered finally. Okay, so this is how we are formatting using the formatter of over here JSP. We have a formatter of JSP, and after formatting we wrote the number of pieces. So this is how the tabular structure will be displayed by fetching it, and every data is there in this pizza order list. So it's a list containing all this data. We are rendering that list over here, then we are closing for each, then closing table, then closing if condition as well. Yeah, so this is what they were expecting over here. Check if the data is available before displaying it. So we checked over here, and then if no data is available, appropriate error message should be displayed. Now, what if there is no data available? What to do then? So we are writing test over here. So it will be linked somewhere in the test cases. So let's see. Now we are done with all the implementations. Only the testing part is remaining. So as you can see, we have this com.accenture.lcam.test over here. When I expand this, we have two tests over here, Pizza DAO wrapper test and Pizza service implementation test. Okay, so what actually we have to do is we have our 1.21 to 1.24 in the Pizza DAO wrapper. So let's open this Pizza DAO wrapper. So you can see we have to dos over here 1.21, 2.2, 2.3, and 2.4. Now let's try to understand how to complete this. Okay, so the first task is this method tests the find all pizza details functionality in pizza DAO wrapper. So we have a reference of pizza DAO wrapper, and the method is find all details. So let's try to call this method by using this reference. Okay, dot find all pizza details, and let's go to the implementation. We know that find all pizza details will give us a list of pizza beans. So it is returning a list. So let's go back to our test and let's create a list here named as list equals to this. Okay, so this is our pizza list. And yeah, so this method, okay, by retrieving the list of pizza details from the database. So what are the to-dos? Implement the test find all functionality pizza details method. Then it should invoke the find all pizza detail method of this. It is invoking it. Next is it should verify that the returned list of pizza bean object is not empty. So it just checks that it should not be empty. So what we have is, since we already have every record which was fetched in pizza list, we have assert, not assert equals to, we have assert not null. Just a minute. So we have to check is, so what we have to check is it should verify that the return list of pizza bean object is not empty. So to check that, we have one method over here which is assert not null, and then we'll be passing our pizza list over here. But with this, we'll be passing one more thing, which is a message. So pizza list should not be null. This method should be displayed if it is null. Okay. And then what we can do is we can say assert false. So it will also check that the list is not empty. So what we'll write a same message over here. List should not be null. However, in this, we have to say that this pizza list which we have dot, it should never be empty. If it's empty, then this will be called is empty. Okay, so it is assert false. Hence, if it's empty, so it will be called. Or we can say pizza list should contain data, whatever you want to say. It's just a message. If it's empty. Okay, so it should not be null, it should not be empty. So these are the two checks which we are doing over here. The next is this one, in which we have to implement the test add pizza order details method, and then create a new instance of pizza order bean and set its property with the dummy data. Okay, so let's create pizza order bean as equals small is equals to new pizza order bean. So we created a pizza order bean. Now let's set its property. So pizza order bean dot set, not capital one, the small one. So we have multiple setters. So we'll set a customer name, and the name is, let's say, Rahman. And then we'll set a pizza ID. So pizza order bean dot set ID in pizza ID. And the pizza ID, let's say, is 1001. And then we have pizza set number of pieces. So let's set number of pieces and let's keep it as 2. So we created a bean object, we attached a value, a set value of it. Now let's call the method to add the pizza order. So we have this pizza order bean and add did order will be received once we'll be calling pizza dough wrapper dot. What is the method name? Add pizza order details, and we are passing pizza order bean. Done. So once it will add it, it will return a pizza order bean which we are storing in added order. Now what we have to do is we have to do some checks. What checks? Verify that the pizza order has been successfully added. So how are we going to verify this? So since we are getting this added order over here, let's check it over here. As I said above, we have assert not null, and we can pass added order over here. So it will say if it's null or not, and then we can pass a message as well that added pizza order should not be null. Done. Next is verify that the order has been assigned an order ID. So we have to check if the order ID is there or not. So we'll say assert not null. So order ID should not be null. But now what we are checking is not complete added order, but from that we will be getting order ID. And then we are checking if it's there or not. Let's print the message as well. Order ID should not be null. Done. So these are the two checks which we implemented over here. Now let's go to the next to do, which says that this method test get pizza price functionality in the pizza dough wrapper. Okay. And by retrieving the price of a pizza from the database. Okay. So implement this test get pizza method, this method, and set the expected price of the pizza. So let's try to first use an int pizza ID over here. Okay. So this is just a variable, normal variable, where we are assigning pizza ID as 1001. And then assuming it's a valid pizza ID, then we are using double expected price should be, let's say, 200. And then since it is double, let's write it in this way. Then what we'll be doing is uh, we'll have to first get an actual price. To get actual price, let's create another variable of double, and its name will be actual price, which will be calling this pizza dough wrappers dot get, I believe, what is the method name? Get pizza price. So this should be small pizza dough wrapper dot get pizza price, and done. Now, to get a pizza price, we have to pass this pizza ID since it takes one parameter. You can see over here. So let's pass it here and done. Now we know two things. One is expected price, one is actual price, and we are doing a testing. So what we'll do is we have an assert true, which is a boolean. So it will say if actual price is greater than 0 or not. So this will be verifying that the actual price is non-negative, which we have to do over here. Verify that the actual price is non-negative. So let's do this. So we have this actual price. It should be greater than equal to 0. It should not be 0. Now if that's the key, If that is not the case, then what message we have to print is price should be non-negative. Done. The next is verify that the actual price matches the expected price. So again, we can use assert equals. So assert equals will check expected price with the actual price. And if they both are matching, then what we can do is we can write a message that price, pizza price should match expected value. Okay, assert equals deprecated. No problem, but it is a good method. Let's write this message here. Should match. If it's not matching, it will print this message. The expected value. Cool. No problem. Let's use this suppress warning as of now. And the next thing which we have to do is to do 1.24. This method tests the get order details functionality in the pizza dough wrapper. So what we have to do is we have to prepare a test data by setting valid from bill and to bill value that exist in the database. So let's try to create this. Let's take two variables. First is from bill equals to, let's say, 100. This will be there, I believe. And then again to bill, let's make it 500. Okay. Now what we'll do is, since we know that in the pizza dough wrapper we have an object, a reference of it. Let's make it small, and then dot. The method name which we are trying to check is get order details, and it takes two parameters. So it takes from bill and to bill, and done. Now let's go to the implementation of this, and or if we can see over here, it will be returning list of pizza order bin. So see here, it will be returning list of pizza order bin. So let's go back over there in the test. Let's create a list of pizza order bin, and let's name it as order list equals to this. Okay. Now we have everything in our order list. What we have to do is, it should first we have to verify that the pizza order exists within the bill range. So it should not be null. Okay. So we know assert not null and order list done. So this will take care that it should be there. It should not be null. And the next thing is we have to verify that the okay, iterate through each pizza order being object in the list and verify that. Okay, so we have to iterate each order and have to verify that it's there in the database. Hmm. Okay, so let's use for loop over here in which we'll be using pizza order bean. Let's take it from here, and then let's use variable as order, and let's iterate this order list, and then let's try to check with assert true. What we are checking is order bill should be within the specified range. So what we can say is order dot get bill, it should be greater than equal to from bill. Correct. Next thing is and we can use this and and order dot get bill should be less than equal to bill. Then now once this if this fails, then we have to print a message saying order bill should be within the specified range. Done. So this will check for all of it that if it's in particular range or not. So what we are doing is iterate through each pizza order bean object in the list and verify that it's in this range or not. So we did 4 test cases over here to 1.21, 22, 23, and 24. And we mostly used not null, assert true, assert equals. These are the only basic things which we have to use. So this was for pizza dough wrapper test case. After understanding all the test cases for pizza dough wrapper, now let's try to come to the final part of our this project, which is pizza service implementation test cases. So in this we have 25, 26, 27, these three to-dos. So let's try to read it and perform accordingly. So the first one is this method tests the get order details with record found and functionality in the pizza service implementation by retrieving the pizza order within a specified bill range from the database. And then what it does is, so what we have to do is implement the this method and then prepare test data by setting valid from bill and to bill value that exist in the database. Invoke the get order detail method of a pizza service implementation, passing the from bill and to bill, and then verify that pizza order exists within the bill range. So we did something similar in this. Let me show you. So in this pizza dough wrapper test, you can see we did we did something similar where we used two values. Oh, not this one, this one. So from bill and to bill, and we declared this value. We tried to get it by using that method, and then we had a check over here. So let's copy this and try to paste it over there. Service implementation, this one, and paste. Okay, let's remove this. Control Z. Okay, fair. Now what it is saying that it doesn't have a pizza dough wrapper. Since we'll be testing pizza service implementation, let's paste it here. It does have this method, and I believe everything will remain same. The next to do is this method tests the get order details with no record found functionality in the pizza service implementation by retrieving pizza orders within a specified bill range from the database when no records are found. So the to-dos are implement this method where we have to do is set invalid form from bill and to bill values that do not correspond to any records in the database. Okay, so let's try to write it down here. Let's paste the same code which we pasted above, but in this we'll be using two different from and to. So let's use -100 and -500 because we are 100% sure that such record is not there in the database. Then what we have to do is then verify that calling this will throw a no record found exception. Okay, correct. So we did this. That doesn't correspond to any of the record. Verify that the no record found exception is thrown when invoking the get order detail method for this one. So when we'll be trying to invoke this, it should throw this exception. So what we'll do is to verify that we'll use exception and then we'll create a reference of it and then we'll assign it a value which will be given by assert throws. So since it will be throwing an exception, we are taking that, and if it's throwing no record found exception, which we are expecting, dot class, then let's implement a lambda function over here. If it will throw this, then what we'll do is we'll use, oh, this will be thrown when we'll be calling this. So let's call it here, done, and semicolon here. So once we are getting an exception in this exception reference, let's try to see if it's correct or not. So what we had to do is verify that this is what is happening, and then let's remove this one since we are not getting any list, and then let's remove both of this. The next part will be we will create a string. So the expected message, we know that what will be the expected message. String expected message is equals to, um, we are sending some message as well over here. So let's go to pizza service implementation and get order details with no records found. Pizza service implementation, get order details. When there will be exception, it will be sending this message. So let's copy this message and go back to our test, and let's paste that message here. And after pasting it, now let's check it by using assert equals. So it will check if the message which we are getting is same as the expected message or not. So what we'll do is we'll check that our expected message is same as exception dot get message or not. So if these both are same, then it's good. Otherwise, we have to say that any message would work. It should compulsorily throw no record found exception only. Done. So verify that the no record found exception is thrown, and verify that the message of the thrown message matches the expected message, which is this, which we wrote over there and which we were passing. So we did this verification and now we are good, I believe. So this was for this one. Now let's move towards the last 1.27, which is saying that this method tests the transactional behavior of adding a pizza order. So in pizza service implementation, by verifying that no changes are made to the database when adding a pizza order. So to do that, we'll have to implement this method, and to do that, we have to prepare a test data by setting valid from bill and to bill values that exist in the database. So we can take it from here. And next is retrieve the initial list of pizza orders using get order detail method of pizza service implementation. So we are retrieving the initial list over here. Then record the initial number of orders. Okay. So now what we have to do is we have to record the number of orders which we have. So we have a list. So let's store its count somewhere. So int initial number of records is equals to um, this order list dot size. Done. So we have the count of initial number of records now. Now what we'll do is we'll create another object, and we can take this object from this test which we created. Over here we have this object. Let's take this one and till here only. Let's go to this. Okay. Now we are creating a new object, and this won't be pizza draw, it will be pizza service implementation. Okay. Okay, so this will be pizza service implementation. And the next thing that we have to do is so retrieve the initial list of pizza orders using this get order details method of this service implementation. So we retrieved it, then record the initial number of orders. We recorded that. Then add a new pizza order using this. We are adding it. Okay, and then record the final number of orders. So to record the final number of orders, um, let's call this again, and we'll name it as final number of orders. And this will be order list 2 to dot size. And then we can write this message over here, which says that transaction should roll back, so order count should be equal. Now this is the initial number of orders. This is final number of orders. Okay. Now why the transaction should roll back is we'll be calling a pizza this method but with rollback. So what we are checking over here is when we add a new pizza order using add pizza order detail method of a pizza service implementation, it should retrieve the final list of pizza orders using get order details method of pizza order implementation. So record the final number of orders and verify that the initial and the final number of orders are equal, indicating that the no change were made on the database. Okay. So this is where we are checking the asset property of this database. Let's remove this one. This is not needed. So we are just checking that if initial number of order and a final number of orders. Oh, I have to update this. Correct. So we are just checking if the initial number of records and final number of records are equal or not. So that's all in this. This was the final and the last implementation of this project. I hope you understood everything, and this is the whole structure. We tried to understand from the beginning, scratch, that how the communication is taking place, how everything is connected with each other, what are the uses of this config files, how we are dealing with beans, how to create a getter and setter methods, to string methods, how to use DAO surveys, how they are communicating, why entity to bean conversion and bean to entity conversion is required, and all these concepts is discussed in this video. Even after this, if you guys have any doubt, feel free to drop in the comment section. We can discuss it there. Thank you so much and all the best for your hands on.